All right, grade 5. Today we're going to continue with what we learned last day and apply it in helping us to describe shapes. Today we're going to be looking at describing 2D shapes. So our big idea again is to describe shapes, 2D shapes, and 3D objects can help me to understand the world and to solve problems. Our concept today is going to be about demonstrating and understanding that the attributes, so attributes are something we can say about a shape, such as the number of sides, the number of vertices, and remember a vertice is a corner. The length of the sides can be used to describe shapes, shapes meaning 2D shapes. Now this is going to be lessons 1 to 4, so it's touching on all of those, just because I think you can manage looking at all of the different attributes that we might describe. So, we can describe shapes by telling about their attributes. Here are some attributes of shapes. We can talk about the lengths of the sides. So here we could say that this shape has 2 lengths that are the same and 2 widths are the same. Okay. Often you'll notice there are marks on a shape that will indicate whether or not they are the same. And you can see here that this shape has one line and one line, which means those are the same length. This shape has 2 hatch marks and 2 hatch marks, which means those are the same length. Sorry, same length, not the same shape, same length. Same thing here with this parallelogram. We can see this parallelogram also has 2 parallel sides of equal length and 2 parallel sides of equal length. So if we were describing this shape, we could say that it has 2 pairs, meaning 2 groups of 2, of 2 pairs of sides of equal length. And to be specific, we could say 2 pairs of parallel sides and use our terminology from earlier, because these lines are parallel, they are not intersecting, they will not cross. Taking a look at this attribute, we could say that shapes have sides that are all the same length. So here we can see that all 4 sides are exactly the same length. Adjacent sides meet or intersect at the vertex. So we could say that these sides are adjacent. That means they're right beside each other. Really, they're connected to each other is what that means. They do intersect. If we were to continue those lines, remember, if we continue those lines, they would cross, which would make them intersecting. In fact, these lines would be perpendicular, would be the better way to describe them. These lines here would be intersecting because they do not make a perpendicular cross. So here we could say this shape has 4 equal lines of the same length. All perpendicular lines are the same length. Here we could say that this shape has 1, 2, 3, 4, 5, 6 lines of the same length. All adjacent intersecting lines have the same length. All right. Continuing to review the different types of attributes, we could talk about the direction of the sides. So we touched on this on the one before, that these shapes have at least 1 pair of parallel sides. This is a pair of parallel sides. This is a pair of parallel sides. Okay. These sides are always the same distance apart. They do not meet. They would not intersect. Okay. We use arrows sometimes to show parallel sides. Okay, so you can see 2 pairs of parallel sides, in fact, here, and 1 set of parallel lines on the trapezoid shape. So reminding ourselves a little bit about what some of these shapes are called. This shape with the 2 diagonal lines that are running parallel and the other 2 diagonal lines that are running parallel would be a parallelogram. This shape with 2 lines running parallel and 2 other sides that would eventually intersect is called a trapezoid. So just to remind yourself the name of that shape. And those do have parallel sides. These next shapes have no parallel sides. When you continue each of these lines, you'll see that eventually they would in fact cross. Okay? Oops. Can't seem to get my pen to go right on that line. There we go. If we extend them, we see that eventually they would in fact cross. Okay? And these we can definitely see that they would eventually cross. They're right at the corner. They would extend and cross as well. So they would all be intersecting lines. We can use our ruler to check for parallel lines. They need to be the same distance apart on either end of the shape. So parallel lines and no parallel lines is another attribute we could use to describe shapes. So far we have side length, we have the direction of the sides, whether or not they are parallel or not, intersecting and perpendicular. So the direction of the sides is one way to describe shapes. The length of the sides is one way to describe shapes. Let's touch a little bit on how shapes are named. Often when we talk about a shape and we name it, we label each vertex, and remember a vertex is a corner, with a different capital letter. This way we can name that shape. And often they write the vertices or the corners in order. So this would be triangle ABC, corner A, B, C. Okay. This helps us to describe the sides. We could say that line AB is intersecting with line BC. Tells us specifically which lines are intersecting. So it's a very good idea when you are describing shapes that you label the corners and then use that to help make your description of the shape very clear. Remember, we are seeking to be understood, so we want to make our explanations as clear as we possibly can. And this is one of the great ways that you can do that. Let's take a look at this quadrilateral. It's named quadrilateral MNPQ, and here we could say that line MN is parallel to line QP, but line MQ and line NP would eventually intersect. All right, let's take a look at a few things here. Let's take a look at this picture on the wall. Oops, sorry. If the picture is positioned correctly, and if you've ever hung pictures before, you have an idea that you want the bottom edge to be horizontal and the top edges to be horizontal, not diagonal. You need them to be straight. And you want the side edges to be vertical, again, straight up and down, not at all diagonal. And here we can say where the edges meet on a shape like this is that the lines are in fact perpendicular. Remember, they make that right angle L shape. So all of the corners on this shape, all of the vertices are perpendicular, we could say. We could say this is a four-sided shape that has two pairs of parallel lines and four vertices that are all perpendicular. Those are some of the ways we could describe this shape. When two sides of a shape intersect that make a right angle, so that's that L shape, they are perpendicular. So we could say all of these shapes have right angles. If we were sorting shapes, we could say that two of the shapes have four right angles and one shape only has two right angles. We could also talk about parallel lines. This shape has two pairs of parallel lines, as does this shape have two pairs of parallel lines. This shape does not. This shape only has one set of parallel lines. If we wanted to talk about side length, this shape has all four sides the same length. This shape has two pairs of sides the same length. These two are the same length. These two are the same length. This shape doesn't appear to have any sides the same length. I would perhaps measure these two just to confirm that, but from first glance it does not look as if any of those are going to be the same length. So those are some of the different ways we could describe. So remember, we could talk about the way the sides intersect. We've added that now. We can also talk about the length of the sides, and we could also talk about the direction of the sides. So the way two sides intersect, the length of the sides, and the direction of the sides. Now, reviewing the naming of shapes a little bit. This shape has 6 sides, so it's called a hexagon. I know you're used to seeing a hexagon that looks more like this, with all of its sides. Pretend here. Woo, that's bad, but pretend that those sides are all the same length. It doesn't actually matter, but this would be the normal hexagon that you're used to seeing. But in fact, hexagon means that it is any side, 6-sided shape. So this has 1, 2, 3, 4, 5, 6 sides. So it is in fact considered a hexagon. So be careful that you don't allow that normal view of a hexagon to be the only hexagon you think of. A hexagon just means it's a 6-sided shape. And again, here we've labeled the sides with letters to make it easier. We can say that AF is perpendicular to FE. Yes, in fact, that is. It makes a right angle. To write that, we could say AF, and then show that perpendicular symbol, is line AF is perpendicular to line FE. We could also say that line AF is perpendicular to line AB, and you can see that here. If we wanted to, we could also say that line AF is parallel to line BC and parallel to line ED. So if we were to continue those lines, we can see that they would in fact be parallel. We could also say that line, sorry, I'm just going to erase a bit here because I can't see the letters anymore. Line FE is parallel to line AB and to line DC. All of those would be parallel. So that's another way we could describe that shape. Another thing that we've touched on a little bit already when we talked about side length is equal sides in quadrilaterals. And again, quadrilaterals are 4-sided shapes. So any 4-sided shape is considered a quadrilateral. Even if it's some odd 4-sided shape, it's still considered a quadrilateral. Okay? I would just erase those ends there. Oops. iPad pen just is not quite the same as the real thing, but you get the idea. Okay? So we could say that a square has 4 equal sides. The diagonals of the square are equal, and the diagonals are perpendicular. So if we were to draw a diagonal line from the corners, we would find that it would be perpendicular in the center. A rectangle has 2 pairs of opposite equal sides. So opposite parallel running sides are equal in length. And if you were to draw the diagonals of a rectangle, they would be equal in length, but they would only be intersecting. They are not perpendicular. A rhombus also has 4 equal sides. They're all tilted and are all diagonal, or the 2 parallel sides on the sides are diagonal. These, in fact, are horizontal. So we could say the horizontal sides that run at the top and the bottom of the shape, and the parallel diagonal lines are on the side of the shape, and all 4 sides are equal lengths. Again, here your diagonals would end up being perpendicular. In a parallelogram, it has 2 pairs of opposite equal sides that are again parallel and equal in length. And that's like a rectangle that's kind of tilted on its side. We could talk about parallel sides in a quadrilateral. We've talked about that already. All squares, all rectangles, all parallelograms, and all rhombuses have 2 pairs of parallel sides. So when you see that, you can assume that it's probably one of those types of shapes. If it is a quadrilateral and it has two pairs of parallel sides, it's likely to be a square, a rectangle, a parallelogram, or a rhombus. A rhombus, remember, has 4 equal sides. A parallelogram, remember, has 2 equal sides. A square has 4 equal sides. A rectangle has 2 equal sides. Noting that with a parallelogram and a rectangle, the difference being that they're tilted to the side, etc. To classify a trapezoid, a trapezoid has exactly one pair of parallel sides. So any shape that has one pair of parallel sides is considered a trapezoid. Okay? Adjacent sides in quadrilaterals. A kite has two pairs of equal adjacent sides. So this side is equal in length to this side. They are the sides that are adjacent, that are connected. These sides are equal, and they are the sides that are adjacent to each other, and they are equal. That makes it a kite. So just helping you to name those shapes based on their attributes. If a shape has two pairs of equal adjacent sides, be they facing in at the bottom or facing out, doesn't matter. As long as there are two pairs of equal adjacent sides, it's considered a kite. As long as there's only, exactly, careful, only, can't have more, can't have less, one pair of parallel lines, it would be a trapezoid. All right, so all squares and all rectangles have 4 right angles. So all adjacent sides are perpendicular, which is the difference between a rectangle and, for example, a parallelogram. Parallelogram, remember, is when it's tilted, and those sides then, or those adjacent sides then, do not make a complete L shape. They are not squares and rectangles then. They are parallelograms or a rhombus, which remember is the square that is tilted to the side. So that's the difference there. The other thing we can talk about is symmetry, and you guys are very good at symmetry already. It's when it's folded in half so that one part matches the other part exactly. Some quadrilaterals have no lines of symmetry, so no matter how we divide this shape, we're not going to get two halves that are exactly the same. So no lines of symmetry. Some quadrilaterals have one line of symmetry where you can see that both sides are exactly the same. Both sides are exactly the same. Both sides are exactly the same. Some quadrilaterals have 2 lines of symmetry. You can see this side would be the same as this side would be the same. These two sides would be the same as these two sides would be the same. Some shapes will have more lines of symmetry as just 2 as well. All right, so when we look at quadrilaterals, which is a 4-sided shape, here are some of the attributes and what we call them specifically. So we have the parallelogram. Opposite sides are parallel. Opposite sides are congruent. That means they are the same length. Okay, the same. To be congruent, they have to be the same. The angles are also congruent, and you can see here that they are intersecting angles as opposed to perpendicular angles. And the sides are the same, opposite sides are the same length. That makes a parallelogram. A rhombus, opposite sides are also parallel, so parallel. These 2 lines are parallel, and these 2 lines are parallel. All sides are congruent, so they are all the same length, and all opposite angles are congruent. And in this case, again, you can see that they are intersecting. So they're intersecting. Angles, and the opposite angles are the same, so you can see these 2 are both acute, these 2 are both obtuse, but the opposite angles are the same. A trapezoid has one pair of opposite parallel sides, so parallel sides that are opposite, that makes it a trapezoid. A rectangle also has opposite sides that are parallel, so parallel and parallel, parallel and parallel. It also has opposite sides that are congruent, and again, that means the same length. So opposite sides are the same length. This side is the same length as this side, and we could use hatch marks here. 2 lines meaning that these are the same length. Opposite angles are congruent, and in fact here we can see that all 4, and I'm going to change this, take that out, all 4 are right angles. So they are all perpendicular corners. Opposite sides are parallel in a square. So again, we have opposite sides being parallel. My pen is just not cooperating here. Okay, parallel sides. All sides are congruent, and in this case, again, that means the same length. They are the same. Opposite angles are congruent. We really don't need, because all angles are right angles, or again, perpendicular. If it's a right angle, we know that the corners are perpendicular. So hopefully that will help you with classifying shapes. Now you get to do some practice. Which of these shapes have 2 pairs of opposite sides that are parallel? Take a look. Work with your elbow partners. Write it on your paper. Which of these shapes have opposite parallel sides? They don't have to be equal. We'll make this shape A, B, C, and D to assist you with describing each shape. Go ahead and press pause and do that now. All right, well, if we were to look at these, we want shapes that have 2 pairs of opposite sides that are parallel. Well, these 2 are parallel, and these 2 are parallel, so A would fall into that category. B, does it have 2 pairs? So again, 2 pairs means there's 4, 2, and 2. So 2 that are the same and 2 that are the same. Here we have 1 set of parallel lines, so it does not fit. Remember, with it having 1 set of parallel lines, it would be considered a trapezoid. C, 2 pairs of parallel lines. Yes, this is parallel to this, and this is parallel to this. It has intersecting corners. It would be considered a parallelogram. And D also has 2 pairs of, not 2 pairs, sorry, 1 pair, 1 set of parallel lines. These 2 are parallel, which would also make it a trapezoid. So here we have 2 B and D, which are trapezoids, A and C, which would be considered parallelograms. And specifically, C would be a parallelogram, whereas A, because all of its side lengths are the same, would be considered a rhombus. All right, take a moment with your elbow partner in your group. Take a moment to describe each shape. Tell some of the characteristics for each shape. Go ahead and press pause now and try that. All right, if I were to describe the orange shape, I could say that it has 1 pair of parallel lines. It has a horizontal line that meets at the vertices to make perpendicular corners. It has 2 non-congruent angles, and it would be considered a trapezoid due to the fact that it has 1 set of parallel lines. The red shape, we could also say, has 1 set of parallel lines. All of its vertices are not perpendicular. The 2 on the bottom would be obtuse, and the 2 on the top would be acute. Side length, we could say the side length of the opposite lines that are not exactly vertical, but are diagonally, vertical I guess, would be the same length. The green shape looks like these two lines are the same length and these two lines are the same length. We could label them to help us, so let's make this A, B, C, D. We could say line AB is equal to line CD in length, and line AC is equal to line BD in length. As far as the corners, opposite corners are equal. Vertices C and vertices B are both acute angles, and vertices A and vertices D are both obtuse angles. As well, they are parallel lines. It has two sets of parallel lines, and it would be considered a parallelogram because its sides are not equal length. Next shape, our purple looking shape, looks to me like all sides are equal in length. All sides are parallel, or opposite sides are parallel. Parallel line to this parallel line, this is parallel to this. Looks like they're all equal length, which would make this then a rhombus. Next one's fairly easy. It's a four-sided equal side length shape. All sides are equal length. All sides of corners are perpendicular or right angles. All sides are, opposite sides are parallel. This side is parallel to this side. This side is parallel to this side. So horizontal sides are parallel. Vertical sides are parallel. This would be considered a square. Our next one, we have opposite side lengths being parallel, opposite sides being parallel and the same length. So this side is equal to this side is equal to this side. All corners are perpendicular or right angles. It would be a rectangle. And our last one here would be what we would consider an irregular shape because none of them are parallel. So it doesn't fit into the trapezoid, rhombus, parallelogram, rectangle, square category. It would be considered an irregular shape. When none of the side lengths are the same, it is considered an irregular shape. We could call this an irregular quadrilateral because it has four sides. Quadrilateral. There we go. All right. All right, that has given you an opportunity to do some practice. You are now going to go on to Math Makes Sense, page 232, 233, numbers 3, 5, and 6, and page 236, 237, also numbers 3, 5, and 6. You're going to use things such as the number of sides, the number of vertices, remember that's corners, the number of, or the length of the sides, the direction of the sides to help you with describing these shapes. Now, when you describe these shapes, you need to be clear, seek to be understood. In order to clearly be able to describe those shapes, you should be labeling the vertices with a letter so you can clearly say, for example, line AC is parallel to line BD and so on. Or it could be that you are using pencil crayons and outlining what sides would be the same. Okay, so you could say the orange opposite sides are parallel or something of that nature. If you are having trouble with how to clearly communicate that, please let me know and I can assist you. Remember, you need to seek to be understood in your work and it needs to be clear for the person who is looking at it. If you have to explain it to them, you haven't done a good enough job of seeking to be understood. Make sure you are very, very clear in what you are describing. Go ahead and give it a try. Make sure if you have questions along the way, please ask. Seek to understand.